that had a 1 in the first position. However, we don't always want to have such simple expressions. We want to be able to put more complicated things in there. So today we are going to learn how to expand when there is two different things, such as x plus y in our brackets. So like we did last time, I'm going to expand the first few out the old-fashioned way. So x plus y to the power of 0 is going to be equal to 1. X plus y to the power of 1 is simply x plus y. X plus y all squared, expanding that with the short method, x times x is x squared. X times y doubled is 2xy. And y times by itself is y squared. If I were to do x plus y all cubed, I would break that apart to be x plus y times x plus y squared. Now the x plus y squared, we just expanded that. That's x squared plus 2xy plus y squared. Then I want to expand that further by multiplying the x by everything in the second bracket. So that's x cubed plus 2x squared y plus xy squared. And then the y times everything in the second bracket would be x squared y plus 2xy squared plus y cubed. Then we have a few like terms that we can collect. The x cubed doesn't have anything to collect with, but 2x squared y and another x squared y will make a positive 3x squared y. And a xy squared plus 2xy squared will make 3xy squared. And finally, the y cubed on the end. Now, hopefully you can see just with the few that I've done already, the coefficients are also following Pascal's triangle. So we have 1, 1, 1, 1, 2, 1, and the one that I've just done is 1, 3, 3, 1. What is important to note though is what is happening with the powers of x and y. Looking at the one that I've just expanded, the x, which was in the first position, when I was expanding out a power of 3, my highest power of x is my first term, starting with an x cubed, and in each term that I go down, the x power decreases by 1. So x cubed, then the x squared, x, and finally no x. Whereas the y, which was in the second position, it starts with no y's and it gradually increases. So none, 1, y squared, and then y cubed. So using that pattern, I could expand out x plus y to the power of 4. Now I would need to use the fifth row of Pascal's triangle for the coefficients. The first coefficient in that row is the number 1. The x is in the first position, so it's going to start out by being x to the power of 4. The y in the second position, there won't be any of those yet. When I go to the second term, the coefficient is a 4. The x power is going to decrease by 1, becoming x cubed, and the y power is going to increase so that now there is one of them. The next coefficient is a 6. The x power decreases again to be x squared, and the y increases to be y squared. The next coefficient is a 4. X decreases again to a power of 1, and y increases to a power of 3. And the last term has a coefficient of 1. The x's will have disappeared altogether, and the y will be to a power of 4. So just like what we learnt in the last exercise, when I'm expanding x plus y to the power of n, there will always be n plus 1, which is one more terms than the power that we are given to expand. Also, the coefficients in the expansion are the same as the coefficients from 1 plus x to the power of n, which means they're the same coefficients that we get from Pascal's triangle. So in examples down here, we want to use Pascal's triangle to work out the expansion of 2 plus 3y all to the power of 4. So because it's a power of 4, we want to use the fifth row of Pascal's triangle, which was the one that I just used on the top of the page as well, which is the 14641. So starting with my coefficient of 1, the term in the first position, which is a 2, starts with the highest power, which in this case is a power of 4. So it will be 2 to the power of 4. The item in the second position, which is 3y, is going to start off with a power of 0 and is going to increase as I go through the question. You don't need to write the 3y to the power of 0 because that will just equal 1, but it can be helpful to see your powers as they change throughout the whole expansion. So let's go on to the next term. The next coefficient is a 4. The 2 is going to decrease to be a power of 3, and the 3y increases to a power of 1. The next coefficient is a 6. The 2 decreases again to a power of 2, and the 3y now becomes squared. The next coefficient is a 4. The 2 decreases to a power of 1, and the 3y increases to a power of 3. And finally, the last term has a coefficient of 1. The 2 is now a power of 0, and the 3y is to the power of 4. Now everything's expanded, but we need to tidy that up. So you may want a calculator to help you with this. First of all, I need to work out the numbers. Now in the first one, I have 1 times 2 to the power of 4. The 3y to the power of 0, that doesn't do anything. So 2 to the power of 4 is simply 16. So the first term just becomes a 16. In the second term, we have 4 times 2 cubed times 3 to the power of 1. That equals 96. And we have y to the power of 1, or just y. For the next term, I have 6 times 2 squared times 3 squared. Timesing all of those numbers together, you get 216 y squareds. And next, 4 times 2 to the power of 1 times 3 cubed. That is also 216, and we have y to the power of 3. And for the last term, the 2 to the power of 0 doesn't do anything. The 1 is not really going to do anything. We just need to find out what 3 to the power of 4 is, which is 81. And we still have the y to the power of 4. So that has been expanded and simplified. On the next page, you want to do another one of these questions that involves fractions. So it is a power of 5, which means we want the sixth row of Pascal's triangle. The first coefficient is always a 1. The first term in that bracket is x squared, which will start with the highest power of 5. The second term, which is 1 over x, starts with 0 and is going to be increasing. The next term along, the coefficient is going to be a 5. The x squared is going to decrease to a power of 4, and the 1 over x increases to a power of 1. Next term, the coefficient is a 10. The x squared decreases again to a 3, and the 1 over x increases to become squared. Next coefficient is also a 10. The x squared decreases again to be 2, and the 1 over x increases to become a 3. Note that the powers always add to give 5. So 5, and so in each of the terms, 5 and 0 is 5, 4 and 1 is 5, 2 and 3 is 5, 3 and 2 is 5. on to the next term. My coefficient is a 5. The x squared decreases to 1, which means my 1 over x is going to increase to a power of 4. And my last term, which has a coefficient of 1, the x squared is down to a power of 0, and the 1 over x is a power of 5. We want to tidy that up. So for the first term, the 1 over x to the power of 0 is just going to be equal to 1. So all I want to do is expand this first bracket where I multiply the powers, and I'm going to get x to the power of 10. Then for the second term, the 5 is the only normal number there, the coefficient. Timesing the powers for this first bracket, 2 times 4 is going to be x to the power of 8. And the x in the second bracket, 1 over x to the power of 1, I could write that as just 1x on the bottom. For the next term, the 10 is going to be at the front. For the first bracket, 2 times 3 makes x to the power of 6. And the 1 over x squared just means I need an x squared on the bottom. The next one, the 10 is at the front. Multiplying 2 by 2, I get x to the power of 4. And I will get an x cubed from the second bracket on the bottom of my fraction. Next one, 5 is at the front. X squared will be the power from the first bracket, and x to the power of 4 for the second bracket. And finally, a 1. The x squared to the power of 0 means there'll be no x's on the top, but the x to the power of 5 will go on the bottom. Now I can cancel off a lot of x's in each of those terms. In the first term I can't simplify, but in the second one I can cancel the x off the bottom, subtract 1 from the top, will be 5x to the power of 7. For the next one, again, I want to cancel 2 x's off this time, which will mean 10x to the power of 4. In the next term, I can cancel 3 off the bottom, so that will make 10x for the top. In the second last term, I've actually got more x's on the bottom, so I want to cancel the 2 off the top, which will give me 5 over x squared. And the last one, there is nothing to cancel. So there it is, all expanded out. Example number 2. It says to expand 2x minus x to the negative 3 all to the power of 4 using Pascal's triangle, and hence find the term independent of x. Independent of x means that there will be no x in that term. In other words, it'll be a constant. So expanding this, it's a degree 4, so we want the 5th row of Pascal's triangle again. So the coefficient, the first coefficient is a 1. The first term is a 2x, and it will start at a power of 4. The second term, which is minus x to the minus 3, is going to start with a power of 0. The next term will have a coefficient of 4. The 2x is going to decrease to a power of 3, and the minus x to the minus 3 is going to increase to a power of 1. And it gets quite repetitive. The next coefficient is a 6. We have 2x to the power of 2 minus x to the minus 3 to the power of 2. The next coefficient is a 4. 2x to the power of 1, so it's decreasing, minus x to the minus 3 to the power of 2. Not 2, sorry, that should be a 3. And one more term, coefficient is a 1, 2x to the power of 0, and minus x to the minus 3 to the power of 4. Now to simplify, for the first term, we want to do 2 to the power of 4, which is 16, and we will have x to the power of 4 from that first bracket. The second bracket's to the power of 0, so it's not going to do anything. Moving on to the second term, we have 4 times 2 cubed times by a -1 to the power of 1, or an odd power with a minus sign, which means that minus sign is actually going to come all the way out to here. 4 times 2 cubed is going to make 32. From the first bracket, I'm going to get an x cubed. From the second bracket, I have an x to the -3. Now, I could put negative powers on the top line here, but I like to keep my powers positive where possible, so I'm going to put that on the bottom and make that a positive power of 3. The next term, because I have my negative sign squared this time, it's going to become a positive, and I'm going to need to do 6 times 2 squared, which is going to be a positive 24. From the first bracket, I'll have an x squared. From the second bracket, -3 times 2 is a power of -6, or an x to the positive 6 on the bottom. The next bracket, my minus sign is an odd power again, which means it will be negative. I want to do 4 times 2, which is just simply going to be an 8. I'm going to get x from the first bracket. From the second bracket, I have -3 times 3, which is going to be a -9, or x to the positive 9 on the bottom of the fraction. And the last term, 2x is to the power of 0, so it's not going to do anything. The negative sign is to an even power, so it's going to become positive. -3 times 4 is -12, so we'll write that down as 1 over x to the positive 12. There is some x's that I can cancel off in the second, third, and fourth terms, so let's just do that. We have 16x to the power of 4. In the second term, x cubed over x cubed will cancel out completely, and I just get -32. In the next term, cancel the 2 off the top, will be 24 over x to the power of 4. And in the next term, cancel 1x from the top, which means 8 over x to the 8, and the last term cannot be simplified. Now, all of that was just to find this term here, which does not have any x's, which is the term independent of x. So let's just write a little conclusion. Therefore, -32 is the term independent of x. Part B says we want to find the term in x to the -4. So x to the -4 is the same as x to a +4 if it's on the bottom of a fraction. We are after the whole term, so that whole term is simply 24 over x to the power of 4, or if you wanted to write it as 24x to the -4. And that's it. Question 3. Find the coefficient of the x cubed in the expansion of x minus 3 squared times 2x plus 1 cubed. So we did one similar to this in our last exercise. First of all, I want to expand out x minus 3 squared. That's just a normal power of 2. We can expand that with our short method. X times x is x squared. Minus 3 times x doubled, we minus 6x, and minus 3 squared makes a plus 9. I also want to expand 2x plus 1 to the power of 3, which we could do with our normal algebraic methods, but since we're doing binomial theorem, let's do that with binomial theorem, and it would be the fourth row of Pascal's triangle, which is the 1, 3, 3, 1 coefficients. So starting with the coefficient of 1, the 2x in the first position will start at a power of 3, and the 1 starts at a power of 0. Then on to the next term, my coefficient would be a 3. The 2x decreases to be squared, and it'll become 1 to the power of 1. Next coefficient is also a 3. The 2x decreases to a 1, and the 1 increases to become 1 squared. And the last term, the coefficient is a 1. I have 2x, which will now be a power of 0, and 1 will be to the power of 3. So all those 1 to the any power is just going to be equal to 1. So it's really the 2x bracket that is doing things in this question. So 2 to the power of 3 is going to be 8x cubed for my first term. The next one, I want to do 3 times 2 squared. That is equal to 12x squared. The next one is 3 times 2, which is 6x. And in the last term, the 2x to the power of 0 does nothing. 1 times 1 cubed is still just 1. So now that that's expanded, I am trying to find out if I multiply x minus 3 squared by 2x plus 1 cubed, I can write those two expansions next to each other. So x squared minus 6x plus 9 times by 8x cubed plus 12x squared plus 6x plus 1. Now I don't want to expand that whole thing out. I am only after the x cubed terms. So I'm going to get, there's going to be 3 of them. If I multiply the x squared by the x term, that would make an x cubed. So 6x times x squared is going to be 6x cubed. If I multiply the minus 6x by an x squared, that would also make an x cubed term, and that would make negative 72x cubed. And finally, the 9, which has no x's, times by the 8x cubed would make an x cubed term. 9 times 8 is a positive 72x cubed. Adding and subtracting those coefficients, 6 minus 72 plus 72 will just make 6x cubed, which means that the coefficient that I'm after is 6. So the coefficient of the x cubed term is 6. And that's it. You're ready to do 15b.